So our topic of discussion today is calculus. We're starting with first principle. So we are only going to cover first principle today. In our classes next week, we'll progress with the other subtopics related to calculus. So something important to take note of before we actually start with our first principle is the formula that we are going to use when calculating first principle. So our formula is f prime x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, this is the formula that we are going to use when calculating first principle. Now, take note that this apostrophe or this dash does not indicate inverse. It indicates a derivative, which is called prime. You also come across f second prime, f third prime, and it can go on until 100, 200, whatever number, or whatever derivative you want to calculate. But when we are doing first principle in grade 12, we stop at the first derivative. Now, how we would read this is f prime of x equals the limit. So LIM represents the limit as h approaches 0 of x of h minus f of x all over h. So whenever we calculate first principle, this is the formula that you should use, and these questions are usually out of 5 marks, and there's always one question in your exam. Okay, so what I'm going to do is I'll start off by breaking it up and then combining it into one equation. And I'll do that for the first 2 or 3 sums. After that, we'll do everything within one sum. The reason that I'm breaking it up is to make it easier for you to understand and easier for you to follow along. Now, something important to take note of when we're doing first principle is that your rules of factorizing are important. Once you put in your formula and once you substitute, our first principle part basically ends. The rest of the way is just factorizing, stuff that you've learned in grade 8 to grade 11, just to factorize and to substitute, okay? So, and something else, all of these questions are from past paper questions, okay? So our first question, question 8.1, we have f of x is equal to 4 minus 3x squared. Now we need to find the first derivative of 4 minus 3x squared. Now how we do that is we are first going to write out our formula, which we've previously discussed. After we write out our formula, we are then going to substitute each component of our formula. Now, as I mentioned previously, I'm going to do that separately and then combine it into the formula. So our formula is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, let us take the individual components. So we are first going to look at that part. F of x plus h. What that basically means is that wherever you see x, just put plus h. So keep in mind our formula of f of x was just 4 minus 3x squared. Now, to get f of x plus h, all we are going to do is wherever we see x, within brackets, we are going to substitute x plus h. So I'm going to repeat that once more. In order to get the first component, f of x plus h, all we do is wherever we see x, we substitute x plus h in brackets. So as you can see, we have x over here. So I'm going to rewrite this 4 minus 3, open and close a bracket, squared. So as you can see, I've changed nothing. All I did was where I have x, I'm putting in my bracket. And in place of that x, I'm going to substitute x plus h. So that is your first part. From there, you can simplify this. So this is going to become 4 minus 3 into. Now, something important to take note of, it is incorrect to just say x squared plus h squared. That is not what you do. Whenever you have, let's say, for example, a plus b all squared, you do not say a squared plus b squared. That is incorrect. What you were supposed to do is repeat this bracket twice and have a plus b, and then multiply it using your FOIL method. Okay, so let us do that with what we have on the left. So here we're going to have x plus h, x plus h. We repeat our brackets twice. From that point, we are going to use our FOIL method. So the first term times the first term. And that is going to give us x squared. So let's quickly bring this down. So this is going to give us x times x. That gives us x squared. We then have x times the second term. So that is then going to be x times h, which is then going to give us positive xh. Next, we're going to multiply the second term in our first bracket times the first term in our second bracket. So that is going to be x from our first bracket times h from our first bracket times x from our second bracket. So that is going to be positive xh. Next, we're going to multiply h times h, and that is going to give us h squared. So using our FOIL method, all we did was multiply the first term in our first bracket times everything in the second bracket. And then our second term in our first bracket multiplied by everything in our second bracket. So x times x, x times h times x, and h times h. After that, we bring our 4 minus 3 down. Something important to take note of is that we cannot say 4 minus 3 and get 1, because that 3 is attached to something. Because it's attached to something, we cannot just say 4 minus 3, okay? So keep that in mind. So from here, we can see that we have like terms, xh plus xh, and that is going to give us x squared plus 2xh plus h squared. Now we are going to multiply this negative 3 into our brackets. So this is going to be negative 3 times x squared, negative 3 times positive 2xh, and negative 3 times positive h squared. So as you can see, most of what we're doing is just algebra related from the content or from the material that you've already learned in grade 8 to grade 11. So from this point, let us bring down our 4 minus 3 into, well, actually, let us not put minus 3 because we're multiplying at this point. So negative 3 times positive x squared, that is going to give us minus 3x squared. Negative 3 times positive 2xh, and that is going to give us negative 6xh. Negative 3 times positive h squared is going to give us negative 3h squared. Okay, so all we've done thus far is simplify the expression. So let us continue. We now need to add up all the like terms. So we actually don't have any like terms to add up. So we're going to stop there. That is only our f of x plus h part. Then we have minus f of x over h. Now we already have f of x from our equation, so we do not need to do anything special for that part. So let us continue with our question. So let us now substitute our part of f of x plus h, and we had 4 minus 3x squared minus 6h xh minus 3h squared. So 4 minus 3x squared minus 6h x minus 3h squared. Now, as per our formula, we put a minus and then our f of x part. We know f of x is 4 minus 3x squared, and that is all over h. So this represents our our f of x plus h, and this represents f of x. Something important to take note of that I actually forgot to put in is that we always repeat the limit part. So I've forgotten to put that in. Just give me a moment to put that in. Okay, so always repeat the limit as h approaches 0 until you substitute 0. So you'll see at a certain point we are going to substitute 0 into our equation, and from that point, or from the point that you substitute, that is where you do not write the limit as h approaches 0. So all the steps before substitution, always make sure that you repeat or you rewrite the limit as h approaches 0. So bring down our limit as h approaches 0. From here, all we need to do is simplify our numerator. So that is going to be 4 minus 3x squared minus 6hx minus 3h squared. Now we have a negative sign before our bracket. So what that means is we are now going to multiply that negative sign into our bracket. So it's going to be negative times positive 4, which is going to give us negative 4. Then we have negative times negative 3x squared, which will give us positive 3x squared. And that is all over h. Now we continue to our next step. So we repeat the limit as h approaches 0. Now all we need to do is add up like terms. So we can see that we have positive 4 and negative 4. So positive 4 minus 4 gives us 0. Then we have negative 3x squared and positive 3x squared, and that is also going to give us 0. So what we will be left with is negative 6hx minus 3h squared all over h. Now, the whole purpose of this formula is to try to get rid of our h at the bottom. We need to factorize and to simplify so that we can get rid of h at the bottom. Once we get rid of h at the bottom, that is when we will substitute h as 0. Because if we were to substitute h as 0 from the beginning, we'd be left with an undefined answer, because 0 at the bottom is undefined, right? Whenever you have a denominator of 0, that is undefined. So our whole goal of factorizing and simplifying is to get rid of that h. So, because we are not substituting as yet, we are going to bring down our limit as h approaches 0. From that point, if we look at our numerator, we can see that we have a common factor, which is h. So I'm going to factor out h. So if you factor out h from negative 6xh, that is going to give you negative 6. If you factor out h from negative 3h squared, that is going to give you negative 3h. And that is all over h. If you struggle with taking out a common factor, what I would do, or what I would suggest, is create a fraction. So take what you are trying to factor out as your denominator, and what you're factorizing that from, which is negative 6xh, you put it as your numerator. So you basically take what you're trying to factorize from over what you're trying to factorize, or your common factor, basically. Now from that point, you divide, so you'll see that this will cancel this, so you'll be left with negative 6x. If you try the exact same thing with negative 3h squared over h, we know that when we divide common bases, we subtract the exponents. So this is basically h to the power 1. So h squared divided by h to the power 1 is the same as saying negative 3h2 minus 1, which will then become just 1. And we know we don't really write the 1, so it's just negative 3h. Okay. Now, let us move on. So from here, we can see that we have the same thing on top and the same thing at the bottom. H on top, h at the bottom. So that cancels out. So what we will be left with is the limit as h approaches negative 6 minus 3h. So from this point, we can see that we no longer have a denominator of h, which means if we were to substitute h, we will not have 0 in our denominator position, meaning that this will not be undefined, which then means that we can now substitute h. So because we are substituting for h, we do not write our limit as h approaches 0. So this is just going to be negative 6 minus 3 into 0, because we've now substituted for h. And that is then going to give us negative 6. So the first derivative of f of x is negative 6. Now, there is a way to check if your first principle is correct. In order to do that, you need to know how to derive without using first principle. It's something that we haven't touched on, or something that we haven't yet reached in our classes. So once we do that, I believe we'll do that next week. So when we reach that point, I'll come back to first principle and show you how to check your answer, okay? So right now, we're only doing first principle. There's still other ways of deriving, other ways of finding a derivative, and there's different representations of a derivative. A derivative can be represented as f prime of x. It can be represented as dy, dx, can be represented as dx. There's so many different ways of representing a derivative, and you need to be able to know how, you need to be able to recognize each representation as well as finding a derivative using each method, okay? So for today, we're only focusing on first principle, so let us proceed. But before we do, does anyone have a question related to what we've just done? Some part that was unclear or that you got stuck on? You can unmute yourself and speak up, or you can type it out in the chat box. Okay, so I see there's a few hands. Rethabile, you have your hand up. What's your question?
Sir, what happened to the X?
Which X?
In the fourth step.
The red writing or the white writing?
The white writing.
The white writing, okay. Oh yes, that is correct. Sorry about that. I left that out. So this is minus 6x, minus 6x, minus 6x. So your answer would be minus 6x. Sorry about that. Thank you, Rathabile, for pointing that out. Okay, then I saw there was a few other hands that were up. Okay, then just give me a moment to check the chats. Okay, then the chats are fine. So let us proceed then. So our next question is basically something similar. So we're going to use the exact same process as we did previously. The only difference in this question is that we are asked to calculate gradient. So once we are done with 7.1.1, I will explain what a derivative actually is and how it is related to gradient, okay? So we have question 7.1.1. We are given that f of x is equal to 1 minus 4x squared. And we know that in order to calculate a derivative using our first principle, we have to use the formula f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let us first start with our f of x plus h part. So we have f of x as 1 minus 4x squared, right? So all we are going to do is where we have x, we are going to replace that with x plus h in brackets. Even if it's not squared, I always recommend that you replace it with the brackets in case there's a number or a sign in front of it that you then need to multiply into the brackets, okay? So f of x plus h would then be 1 minus 4, and would replace it with brackets. And because this is squared on h, we will also put a squared on our brackets. From that point, we substitute x plus h into our brackets. So from here, let us simplify f of x plus h. So that is going to be 1 minus 4, and we're going to write this twice. So that's going to be x plus h, and that is then going to be 1 minus 4 into x squared plus 2xh plus h squared. From that point, we're going to multiply the negative 4 into the brackets. So that is then going to be 1 minus 4x squared minus 8xh minus 4h squared. Now there's no like terms, so we cannot simplify that any further. So all we are going to do is take that and substitute it into our formula. So our formula is f prime of x equals the limit as h approaches 0 of f of x plus h. So in place of f of x plus h, we are going to substitute what we've just simplified on the left side. So that is then going to be 1 minus 4x squared minus 8xh minus 4h squared minus, now we need to substitute f of x. And our f of x value was, or equation was given as 1 minus 4x squared. So always put your f of x part in brackets so that you can multiply the negative into that bracket. And don't forget something that's very important. Always bring down that negative sign, irrespective of whether f of x is positive or negative. Let's say, for example, we were given f of x as negative 1 minus 4x squared. So don't now not put the negative in front of the 1 just because the formula has a negative. You then substitute that negative after the bracket, okay? So be extremely careful with that. It's those small errors that can make you lose marks, because this is quite an easy part of calculus. To be able to find first principle is something where you should be able to get all 5 marks, okay? And it's asked in every single prelim and final paper. You can have a look at all the past papers that you can get your hands on. It's always in there, and it's always usually 5, 6 or 7 marks. So it's an easy 5 marks that you can score. So make sure that you understand and that you are able to find first principle. Okay, so let us proceed. We know this is over h, so let us continue. So we've got f prime of x equals the limit as h approaches 0. Now all we need to do is we need to multiply this negative sign into our bracket. So we're going to bring down 1 minus 4x squared minus 8xh minus 4h squared minus 1 plus 4x squared. So be careful with the signs. Negative times positive 1 is negative 1. Negative times negative 4x squared is positive 4x squared. And that is all over h. So let us proceed to our next step. So from here, all we are going to do is add up our like terms. So here we have positive 1 and negative 1, which will give us 0. Next, we have negative 4x squared and positive 4x squared, and that'll also give us 0. So we are then left with negative 8xh minus 4h squared all over h. Now from this point, you can see that what you are left with has a common factor of h. So f prime of x equals the limit as h approaches 0. Now let us take out our common factor, which is h, and we will be left with negative 8x minus 4h all over h. Now, from this point, we can see that the top will cancel out with the bottom. So we will therefore be left with negative 8x minus 4h. Now, because we no longer have a denominator of h, meaning that we will not have a denominator of 0, we can now substitute h equals 0. So that is then going to be f prime of x equals, now we are not going to write the limit part because this is the step whereby we substitute. So that is going to be negative 8x minus 4 into 0, and that will give us a final answer of negative 8x. Okay. Now, let us go to the second part of this question. So we had hence calculate the gradient of the tangent to f at x equals 2. So how do we relate a derivative to gradient? So let's have this function x squared as an example, right? So this is y equals x squared. Now let's say at this function we have a tangent. So keep in mind that a tangent is a straight line that cuts the graph at one point, whereas a secant cuts the graph at 2 points, okay? So always be able to differentiate between the two. So let's say we have this tangent that's cutting our graph at that point. So this is the point that it is cutting our graph. Let's call that x. That's the point, okay? Let's just call it P actually. So we have this tangent that is cutting our graph at point P. So if we were to derive the function of f, or if we were to derive the function x squared, so if we were to derive it, we'd end up with the first derivative equals 2x, right? Now, what does this represent? What does the derivative represent? The derivative represents the equation of the gradient at that particular point. Because keep in mind that the gradient of a parabolic function is not constant, right? But the gradient of a tangent, because it's a straight line, is constant. So the gradient of your parabolic function will be different at each point. But at that specific point P, if you substitute the x value, you will get the gradient at that specific point. But what this derivative represents is the equation of the gradient at every single point. So at each asterisk, at each point, you are able to find the gradient at each point using a derivative if you were to substitute the x value at that point. So let's call this point A. If you wanted to find the gradient at point A, you would use this. So keep in mind, we won't use m equals change in y over change in x. We can just use the equation of our derivative in order to find the gradient at each point. And if you want to find the gradient of the tangent, you will use the equation of your derivative to find the equation of the tangent at that point. So if you want to find the equation of the tangent that cuts or that touches the graph at point P, you will substitute the x value of point P to get the tangent at point P. So let's do a quick example of how can we find the equation of the tangent at point P using the graph y equals x squared. So let's say point P has coordinates 1 and 2. Actually, let's make it 2 and 3. So 2 and 3. So those are the coordinates of point P. Now, if we want to calculate the gradient at point P of the graph y equals x squared, we substitute 2 into our equation. That'll give us the gradient at that point. If we want to find the gradient of our tangent that cuts or that touches the graph y at point P, we will therefore substitute the x value at that point, which is 2. So our gradient of our tangent will therefore be equal to 2 times, what is our x value? It's 2. And that'll therefore give us a value of 4. So the gradient of our tangent that touches the graph y equals x squared at point P is equal to 4. And if you want to find the equation of that tangent, all you need to do is use your equation of a straight line formula, because keep in mind a tangent is a straight line. And substitute the gradient and the x and y value. So the y value is 3, the gradient is 4, the x value is 2 plus c. That'll give you 3 equals 8 plus c. And simplify that, that is going to give you c equals -5. Therefore, the equation of that tangent will be 4x minus 5. Now that is the equation of the tangent at our point P for the graph y equals x squared. So before we move on to question 7.1.2, does anyone have any questions relating to how we found the equation of the tangent? Okay, so Princess, is it always y prime equals 2x? No, it is not always y prime equals 2x. Keep in mind your derivative can be anything. Remember, we previously found in question 8.1, the derivative was, I believe, -6x. In this particular question, we found the derivative was -8x. So your derivative can be anything depending on the original function that you were given. So in this case, we found our derivative. Keep in mind that this, it might be slightly confusing because I used a different notation. Keep in mind this y prime represents f prime of x. This y represents f of x. So keep in mind, it's just the derivative representation. I could have even just as easily wrote it as dy dx equals 2x. You can write it in whatever notation that you feel comfortable with. Yeah, so it is not always y equals or y prime equals 2x. Depending on the function that you are given, you will use the appropriate derivative by finding it, okay? So in this particular case, I didn't use first principle to find the derivative because first principle, to be honest, is extremely long and time consuming. As you can see, the method that I used is just your normal finding a derivative method, which is y equals x squared. It's a method that we'll have a look at in next week's class. You'll see that we'll be able to find it much more easily and faster. All you have to do in this method is just multiply the exponent by the coefficient, 1 times 2, subtract 1 from the exponent, and that's it. That's the method. There's just 2 steps. Okay. Also, any constant is 0. So basically 3 steps. Okay. But let us not focus on that for now. We'll have a look at that in next week's class. For now, what I want you to take note of is the method of finding your equation of a tangent. Everything is as you already know it from previous grades, the method of finding an equation of a straight line. The only difference is how you find gradient. So in this case, you are given one coordinate on that line and you are expected to find gradient. You know from previous cases, in order for you to find gradient, you need two coordinates on that line, right? So in this case, you can find gradient by using one coordinate on the line. A quick question, Princess, was your question aimed at this case only, whereby you said, is it always y prime equals 2x for all questions, or did you mean that in order to calculate any point gradient on this curve, must you use y prime equals 2x? Please can you clarify, because those are two different questions that have two different answers or explanations associated. Oh, for all questions. OK, no. Then if it's for all questions, no, you do not use y prime equals 2x. You use the specific derivative associated to that function that is given. Then there's another question. I didn't get the gradient part. OK, so the gradient part, right? All you need to do for the gradient part is to derive. The reason I didn't go back and use first principle to derive is because we've already done that in 7.1.1. That's not important. What I want you to focus on is the process of how we find the equation of the tangent, so that you can apply that process to what we are going to do in 7.1.1. Because keep in mind, we've already found the first derivative, which is negative 8x. So this is your equation of your gradient for what was the original function? 1 minus 4x squared of f of x equals 1 minus 4x squared. So this negative 8x is the equation to find the gradient at any point on f, or to find the equation of the gradient, or to find the gradient of the tangent at any point on f. OK, so that is why I didn't go back and repeat the process of finding a derivative. So assuming that was stuck on the gradient part, all you need to do is, after you find your derivative, substitute the x value of that point into your derivative. Once you substitute the x value at that point into your derivative, that will give you the gradient at that point. For example, let's look at another curve, right? So eventually you're going to come across a cubic function. That's part of calculus. So let's say you have this cubic function, and this cubic function has f of x equals x cubed, for example. OK, so we have this cubic function. Now on this cubic function, we have a tangent at that point. Let's call that point P and give it coordinates 2 and 3. OK, so same as before. And this blue line would represent our tangent. And let's make this minus x squared plus x minus 4, for example. OK, so if we want to find the gradient of this cubic function at point P, or if we want to find the tangent, the equation of the tangent at point P, all we would need to do is, in order to get gradient, because we only have one coordinate on the line or on this tangent, all we need to do is to derive the equation of the curve, to derive f. So if we were to derive f, if we were to get f prime of x, That would then just give us 3x squared minus 2x plus 1. So that would be our derivative of f. That's if you were to use first principle, you'd end up with that at the end, okay? For the sake of time, I'm not going to do that. But if we were to use first principle or whatever derivative method you want to use, that would be our first derivative. This represents the equation of the gradient. So if you want to get gradient at any point on this curve, this is the equation that you would use. Instead of using m equals change in y over change in x, or y2 minus y1 over x2 minus x1, we are using a derivative in calculus. So think of it as this is basically your gradient equation. So I'll put an m in front. Maybe that would make it easier. M equals, okay, so that is your gradient equation. Now, because we are trying to find the gradient at point P, you are then going to substitute the x value at point P. Now, because our x value at point P is 2, you are now going to substitute 2 in place of that. So your gradient would be equal to 3 into 2 squared minus 2 into 2 plus 1. That would then give you 4, 12, 12 minus 4 is 8, 8 plus 1 is 9. So that would then give you 9, okay? So that would be your gradient of the tangent, and it would be your gradient of your cubic function f of x at that particular point P. Rethabile, hopefully that should clear up the confusion. Okay, so there doesn't seem to be any other questions in the chats, so let us now proceed to question 7.1.2. So we've already covered how do you find the gradient and how do you find the tangent, okay? So if we look at question 7.1.2, hence calculate the gradient of the tangent to f at x equals 2. So in this particular question, we do not need to calculate the equation of the tangent. We only need to calculate the gradient of f at x equals 2. So if I were to draw this, this is an a less than 0 graph. So it's going to be a sad face graph. So our graph basically looks like this. Okay. So this is our graph F. Now on F, there is a tangent at x equals 2. So let's quickly draw a tangent. Keep in mind that when you are answering this question, you do not need to draw the graph, nor do you need to draw the tangent. I'm just drawing it so that you can visually see what I'm saying, as I feel it deepens your understanding, or it's much better to explain while you can see something. So our tangent would be there. And also keep in mind, you can have multiple tangents at a particular point. You can even have multiple tangents on a graph. This one particular graph could have like 1,000 tangents. You could have just had tangents here, 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 here. All of these could have been tangents. As long as these tangents are cutting, or not even cutting, as long as these tangents are touching the graph at one point, it is considered a tangent. So as long as that line touches the graph at one particular point, it is called a tangent. If this graph were to cut the graph, if the line were to cut the graph at 2 points, it would be called a secant. For example, if we have a line like this, do you see it cuts at that point and it cuts at that point? So it is known as a secant. it's not that important to know what a second is. I believe I've only seen a question relating to seconds maybe once in past paper questions. It's not something that's frequently asked. So at this point where our tangent touches our graph, that is x equals 2. So we don't need the y value in order to calculate the gradient. We only need the y value in order to calculate the equation of the tangent. Keep that in mind. So in order for us to calculate the gradient, we need to have the first derivative. And what is our first derivative? We previously calculated that in question 7.1.1. That was negative 8x. So keep this in mind. In order for you to calculate the gradient, you need to have the equation of your derivative. So our derivative was negative 8x. So if we want to find the gradient, all we do is substitute 2. So that is going to be negative 8 into 2. And our gradient at x equals 2 is therefore equal to negative 16. Okay, so let us move on to the next question. So our next question is something similar to the previous one. You can see that the x value is the same as well. So we're basically just repeating what we've done previously. So we have question 8.1. Determine the first derivative of determine the first derivative or determine f prime x from first principles. So we have f of x equals to 1 minus 3x squared. Now, in this case, I'm not going to separate my f of x plus h, as I feel like you should be okay with it by now. So all we are going to do is what we previously done of separating it, then putting it into the equation. I'm going to do all of that within one equation. So we have f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Keep in mind that this formula is at the back of your formula sheet in case you forget it or in case you struggle with memorizing formulas. All you can do is revert to the back of your exam paper and there is a formula sheet whereby you will find this. So let us substitute f of x plus h. So same thing as before, I'm going to rewrite it, and in place of x, I'm going to put x plus h minus f of x is given as 1 minus 3x squared, and that is all over h. So just as before, all we are going to do is simplify. So that's going to become 1 minus 3 into x squared plus 2xh plus h squared minus 1 plus 3x squared. And that is all over h squared. H, not h squared, sorry. Okay, so from here, just as before, all we are doing is simplifying our numerator. So this is going to be 1 minus 3x squared minus 6hx minus 3h squared minus 1 plus 3x squared all over h. Now, as you can see, we have +1 and -1, and we have positive 3x squared and negative 3x squared. So those will result in 0. And we will be left with negative 6hx minus 3h squared all over h. And that is then going to give us the limit as h approaches 0. And now we're going to take out our common factor, which is h into negative 6x minus 3h all over h, and the h on top, h at the bottom will cancel each other out. So that will leave us with the derivative of f of x equals the limit as h approaches 0 of negative 6x minus 3h. From this point, because we no longer have h at the bottom, meaning that we will no longer have a denominator of 0, we are then going to substitute h into our equation, and we are not going to use, or we are not going to repeat or bring down the limit as h approaches 0, because we are substituting h equals 0. So this is going to be minus 6x minus 3 into 0, and we will therefore have f prime of x equals negative 6x. So because we have our derivative, because we have f prime x, keep in mind that that represents the equation of our gradient, we can now answer question 8.2, which is hence calculate the gradient of a tangent to f at x equals 0. So I previously drew the equation. It's not the equation, I previously drew the graph. For this case, I'm not going to do that. So let us just quickly answer this. So we have f of x as 1 minus 3x squared, and we need to find the gradient at x equals 2. So something important to take note of is how we find the gradient in calculus is our gradient is equal to the derivative of that function. And we know that the derivative of that function was negative 6x. So we now know that m equals negative 6x, whereby x equals 2. So all we do is substitute 2, and our gradient of graph f at x equals 2 is therefore negative 12.
So to ask if the equation that we're given for the, what do you call this? The equation, is it always going to be a binomial?
No, it won't always be a binomial. The reason that this particular, wait, did you say, is f always going to be a binomial, or is the derivative always going to be a binomial?
The f.
Oh, f won't always be a binomial. Keep in mind, remember I previously showed you that cubic function, this one over here. F is a polynomial there, and you can see that the derivative is a quadratic function. So keep in mind, when you derive, it becomes 1 degree less. So if f is given as a cubic function, when you derive, it's going to be 1 degree less. So 1 degree less than a cubic is a quadratic. If you were to derive that quadratic, 1 degree less would give you a linear function. If you derive that linear function, 1 degree less would give you a constant. Yeah, but you can even start off with like x to the power 10 and keep deriving and deriving till you get to 0. You won't always just find the first derivative. You can find the second, third, the 100th derivative should that function have a 100th derivative. Yeah, does that answer your question?
Yes, thank you.
So our next question, we have 9.1, right? So we are given f of x as 3x minus x squared. And we need to now find the derivative or the first derivative of f using our first principle. So our formula is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So let us bring down our limit because we are not substituting h as yet. Now from that point, we are going to substitute f of x plus h. Keep in mind that this is going to be slightly different from the previous ones that we did. As you can see, there's 2 x's in here, right? So we are going to have h, or rather x plus h, repeated twice. Okay, so that is then going to be 3, and we have an x there, minus, there's an x there, so we put our brackets. Okay, now in place of those brackets, we just put x plus h, x plus h. Okay, so all we did was wherever we had x, we put x plus h. Now we're going to subtract f of x, which is 3x minus x squared. And that is all over h. Now from this point, we bring down our limit as h approaches 0, and we simplify our numerator, which is going to be 3x plus 3h minus x squared minus 2xh minus h squared. Now we multiply this negative into our bracket, and that is going to be minus 3x minus, or rather, I don't have a cable, plus 3x squared. So all we did was simplify our numerator. Now from here, we need to add up our like terms. So we have 3x minus 3x, which will give us 0. And then we have negative x squared. Sorry, this last part is an error. This is just supposed to be positive x squared. So we have negative x squared and positive x squared. Those are our like terms. So we will just add those up. That'll then give us 0 for those particular terms. Okay, we don't have any more like terms. So from that point, we can just write down what we are left with, which is just 3h minus 2xh minus h squared. So we'll bring down our limit because we have not yet substituted h as 0. We bring down what is left, 3h minus 2xh minus h squared. From this point, we can take out our common factor, which is h. That'll give us the limit as h approaches 0 of h into 3 minus 2x minus h all over h. And as we can see, the top will cancel out the bottom h. So that is then going to give us the limit as h approaches 0 of 3 minus 2x minus h. From here, we can now substitute h. So because we are substituting h, we are now going to not write our limit part. So that is then going to be 3 minus 2x minus 0. And that will therefore give us 3 minus 2x as the limit of f. Or as the first derivative of f, rather. Excuse me. Okay, so that was how we found our first derivative. Now, the second part of the question, determine the average gradient of f between x equals 1 and x equals 3. So if we are meant to determine the average gradient between those 2 points, what we can do is there's 2 methods that we can make use of. So we can just use our normal gradient method, or we can use the derivative method because we are given 2 points. So what I'm going to do is I'm going to first use the normal gradient method that we are all used to. So our normal method is the gradient equals y2 minus y1 over x2 minus x1. Now, because we are only given the 2 x values, we now need to obtain the corresponding y values. So let us substitute x equals 1 and x equals 3 into our formula in order for us to obtain the y value that is associated with x equals 1 and the y value that is associated with x equals 3. So that is going to be f of 1 equals 3 times 1 minus 1 squared. And that'll then give us 2. We then have f of 3 equals 3 into 3 minus 3 squared, and that is then going to give us 0. So we now have the corresponding y values to our x values. So let's substitute. So I'm going to make this x1, x2. That means this will be y1 and y2. So that will therefore be 0 minus 2 over 3 minus 1. So 0 minus 2 will be negative 2. 3 minus 1 will be positive 2. Therefore, our gradient will be negative 1. Okay, so that is the normal method that you were used to, and it's something that you can use if you were given if you were given 2 x values. Okay, if you want to use the derivative method, what you can do is do what we previously did, which was substitute the x value into your derivative, because keep in mind the derivative represents the equation of our gradient. Now, once you've substituted the derivative into once you've substituted the derivative into, not the derivative, sorry, what am I saying? Once you've substituted the x values into your derivative equation and you've obtained your gradients, keep in mind the question stated average gradient. The reason that they've stated average gradient is because the gradient of a quadratic function, which is what that is not constant, okay? So because it's not constant, that is why they mentioned the average gradient. So once you've obtained the gradient at both those points, you know how to find average. All you do is you add up the independent values and you divide it by the number of data points. So let's do that. So we were told that we need to find the average gradient between x equals 1 and x equals 3, keeping in mind that gradient represents, or the equation for gradient is our first derivative for this particular case. So if we want to find the gradient at x equals 1, that'll be f prime of 1, which is then 3 minus 2 into 1, and that will give us 3 minus 2, which will be 1. If we want to find the gradient at x equals 3, that is then going to be 3 minus 2 into 3 equals, that is going to be 3 minus 6, which will be negative 3. Now, how do we find average? We are just going to add up 1 and negative 3. And because we have 2 data points, we're going to divide by 2. If we had 3 gradients, we divide by 3. If we had 4 gradients, we divide by 4, and so on. So the average gradient is going to be equal to 1 plus negative 3 divided by 2, which will then give us negative 1. So as you can see, irrespective of which method you use, you end up with the same answer. Whether you use your normal gradient formula that you are used to, or you use the derivative method of finding gradient, you end up at the same answer. The only important thing to take note of is that we can only use our normal gradient formula when we have 2 coordinates on that particular line or that particular curve. If we only have 1 coordinate, or if we are only given x, 1x value, we then need to use our derivative method for calculating gradient. Okay, so let us proceed to the next question. So our next question, 8.1, we need to find f prime of x using our first principle. So we have f of x equals negative 2x squared plus 6x. We know our formula is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. From this point, all we are going to do is substitute that f of x plus h. How do we do that? Wherever we see x, we substitute x plus h. That's all. So step 1, bring down the limit as h approaches 0. Then rewrite f of x, but wherever you see x, you put a bracket. And in that bracket, we are going to put x plus h. Minus, so we bring down our negative sign. Excuse me. So we bring down our negative sign, and then we substitute f of x. So that is then going to be negative 2x squared plus 6x all over h. From here, all we are going to do is simplify our numerator. So we repeat our limit part, and then we have negative 2x squared minus 4xh minus 2h squared plus 6x plus 6h plus 2 x squared minus 6x. And that is all over h. Now what we need to do is find our like terms. So we have negative 2x squared, positive 2x squared. That becomes 0. We then have positive 6x and negative 6x. That becomes 0. We are then left with the limit as h approaches 0 of negative 4xh minus 2h squared plus 6h all over h. From this point, we can take out our common factor of h, which then becomes h into negative 4x minus 2h plus 6 all over h. That then becomes the limit as h approaches 0 of negative 4x minus negative 4x minus 2h plus 6. Okay, so reason we don't have a denominator anymore is because our top h cancelled out our bottom h. Now, from here, because we are substituting h equals 0, we are now going to leave out the limit as h approaches 0, which then means our f prime of x equals 4x minus 2 into 0 plus 6, and minus 2 times 0 is just 0. So that will just become 4x plus 6. And that is our first derivative of f using our first principle. Okay, so it's already 5-3. So let us actually get started with our physics stuff. Before we get started with physics, does anyone have any questions related to anything that we've just done so far? Because keep in mind, this is not the entire calculus topic. This is just the first part. Okay. Next week, we'll have a look at all the different representations of our derivatives. The reason I've chosen to keep this part separate is because the method that we use here is extremely different to what we are going to use next week. The methods are extremely different, okay? So next week, we'll have a look at dy dx, dx, f prime x, all of those different notations and all of those different methods of finding a derivative. Yeah. Okay, why did the negative sign drop? Let's see, what negative sign? Let's see. Oh, yes. Sorry about that. Yes, Danae, you are correct. There is a negative sign there. So this is negative 4x plus 6. The negative sign was not supposed to disappear. That is an error on my part. So, like I said previously, does anyone have a question so we can resolve that before we move on to physics? Okay, so I see there's a few questions. Okay, so Rebecca, some of us okay. Yes, Rebecca, I do understand that some of you are seeing calculus for the first time. That is why I've chosen to take it slow and only do one topic for today. Okay, Princess, you said you didn't understand the last part. You sent that message about 5 minutes ago. Okay, last part. When you say last part, which part are you referring to specifically? Are you referring to the part whereby we substitute 0? Or are you referring to the part whereby we found the average gradient in the previous question? let's see. The gradient part from the previous question. Okay, so the gradient part from the previous question, okay. Okay, so because they mentioned average gradient, all I did was I found the gradient at 2 points. We previously found the gradient at 1 point, so it's something that we've been doing. I think we did it 3 times already, so hopefully you should be okay with that part. How to find the gradient at 1 point. All we do is substitute our value of x at that point into our derivative. That gives us the gradient at that point, right? So that is our gradient at that point. Now, because they wanted average gradient, you know that whenever you find average, all you do is you add up all the components and you divide it by the number of components. That's how you find average. So, for example, let me try to represent this as a drawing. Okay, so let's represent it as a drawing. Is it a greater than 0 or less? It's a less than 0, so it's a sad face. So this is basically our function f, right? Now we have at 1 and 3. So let's say 1 is about here and 3 is about here. So this point is x equals 1 and this point is x equals 3. Okay, so basically we can have 2 different tangents at those points. But what we now need to do is we now need to find the average gradient between those 2 points. So we are basically finding the gradient of the second between those 2 points. Or another way to think about it is you are finding the gradient of a straight line that cuts through those 2 points. Because remember I previously said that average gradient just refers to adding up those 2 points or adding up the number of points that you have and then just dividing it by those data points. Okay. So all we're doing is we're going to find the gradient of that straight line. The gradient of that straight line is that -1. If you don't want to use the derivative approach, you can use the normal gradient approach. But keep in mind, if you are going to use the normal gradient approach, because you are given the x values only, you now need to substitute those 2 x values into the function in order to obtain the y values. Okay.